My name is Snehal Antani. I'm the co-founder CEO at Horizon3. My background, I was the CIO at GE Capital, the CTO at Splunk, and left industry to serve within US Special Operations as its first Chief Technology Officer. And that's where I met my co-founder, Tony, and when he retired from the Air Force and I finished my time in Special Ops, we started Horizon3 together. And what I want to start with is a story about geopolitics and what's happening globally, and then talk about Horizon3 and what we've done as a company. So in 2022, the Japanese provided support to the Ukrainians. And allegedly, the Russians got angry and ransomwared a small company in Tokyo. That company in Tokyo provided all of the cup holders to Toyota. And due to just-in-time logistics and lean manufacturing, Toyota had to shut down 28 production lines, costing almost $400 million of economic damage over cup holders. And the flex by the Russians was not that they could ransomware a small company. It's that they knew where to apply the least amount of effort to cause the maximum amount of harm, all below the threshold for war. And so what we're entering is this role of cyber-enabled economic warfare, where it's not just your burden to secure yourself, but you also have to worry about the security of your critical suppliers and your critical distributors. And that cyber attacks are shifting from being about ransomware, which is extortion, a financial decision and a cyber insurance decision, to about operations. Can you actually build and deliver your product and bring it to market? What effect will a disruption in cash flow because of that cyber operation will have on your own business or the business of your providers and your suppliers? And so as a CIO, the job has never been harder. Because when I was a CIO, I worried about insider threat and security of my on-prem and cloud services. And now, in addition to on-prem, multi-cloud, and SaaS security, I have to worry about the security of my suppliers and my distributors. And so the job is becoming that much harder every day, which is why I'm not a CIO anymore. Now I'm a founder. The other interesting thing is the role of AI in offensive cyber operations. So there was an article that came out from Microsoft and OpenAI on the role that Gen AI plays in offensive cyber and hacking. And if you look at what they talked about, it was the role of hackers using ChatGPT to do open source intelligence and reconnaissance of a target, reverse engineering or understanding protocols, or creating highly convincing spear phishing email attacks. And that's cool. You know, it just feels like a slightly better Google search to some degree. What's really interesting to me is the role of AI in autonomous agents. So how can autonomous agents be used to execute full profile offensive attacks? And that's actually what we ended up pioneering and inventing at Horizon3, the role of autonomous agents to execute penetration tests. And it's a good parallel to understand what we're doing to see what the attackers are going to be evolving over time. In 2022, our autonomous agent successfully hacked a bank in 7 minutes and 19 seconds. Not a single human was involved in this attack, and that autonomous agent knew nothing about the environment. It assumed breach, so it started on a single host with no privileges, no information, conducted recon, enumeration, and discovered the environment, organized all of its discovery into data structures that allowed it to make self-directed decisions, and chained together misconfigurations, harvested credentials, exploitable vulnerabilities to achieve domain compromise. 7 minutes and 19 seconds. A year later, we had a 9-year-old kid point, click, and shoot in the product and hack a bank in 4 minutes and 12 seconds. And it wasn't a child prodigy, that's just how easy it is to leverage offensive cyber through autonomous agents. And so we are seeing this democratization or the decreased barrier of entry for a person with no skills to run full profile cyber attacks, especially if you have the right experience. And so if you look at this trajectory, in less than 60 seconds, you should be able to see a full profile attack compromise your environment. So as CIOs, in 60 seconds, can your team detect the alert, characterize the risk of those alerts, and take action before you get locked out of the system? And the answer is probably not. And so for me, the future of cyber is autonomous. It's algorithms fighting algorithms with humans by exception. And I think that understanding the evolution of penetration testing is a great way to understand the evolution of attackers. Does that make sense so far? Okay. So let's look at the evolution of penetration testing. So if you think about the early days, it was about manual consultants. So very manual effort, very bespoke expertise, and these pen testers thought of themselves as artists because of what they had to go off and do. And then you saw the role of marketplaces, whether it's BugCrowd or HackerOne doing bug bounties. But we saw the same thing happen with the bad guys. They created marketplaces for initial access or data brokers or or harvested credential brokers. And so you saw this marketplace type approach that made it easy for people to contribute to that offensive operation. On the defensive side, you saw this short window of compliance automation. And you actually have a number of companies that tried to do compliance automation. Most have failed to break out to be big companies. And a big reason why is automated pen testing, in my opinion, is an impossible task. There are way too many permutations and variations in the environment. And you can't just create a run book or a bunch of scripts and execute. Think of when IBM played Garry Kasparov in chess. IBM didn't hard code 40 million chess games. They looked at every piece on the board to determine the next best action. And the more games it played, the smarter the system became. And so when I thought about the compliance automation world and those companies, what they tried to do was hard code 40 million chess games. And that's why you end up spending more time maintaining those runbooks than actually testing your environment. And there's this really interesting chasm between automated and autonomous, where you discover the environment, you run next best actions, and the more pen tests you run, the smarter your system gets. So as an example at Horizon 3, we will run more pen tests this year than the entire history of computing. I run more pen tests a day than the largest global consulting company does in a year. And the more pen tests you run, the smarter the underlying system becomes as you think about collective intelligence, reinforcement learning, and other techniques like that. In many ways, at Horizon 3, I'm a data company. Pen testing is just a sensor. And that's the way that attackers think as well, as they collect training data or telemetry from their operations. Now, the other interesting thing here is when you think about being able to execute autonomous systems, cloud-native SaaS architectures are absolutely critical to do this. And the reason why is if we run a pen test against 10,000 hosts, we're generating a knowledge graph with 1 billion nodes and edges. And each node and edge represents every host, port, service, credential, defensive tool discovered, and how they're all interconnected and related to each other. We have customers running pen tests with 200, 300, or 1 million IPs in one test. Those knowledge graphs grow to be 1 billion, 10 billion, or even more, multiple tens of billions of nodes and edges in those graphs. And those graphs are what's important in understanding how to maneuver and to compromise your environment. The other thing that's really important here in cloud-native architecture or SaaS architecture for pen testing is when a new vulnerability is announced by CISA, a CISA KEV, time is the enemy. You want to rapidly take that CVE, reverse engineer it, build the exploit, and immediately make it available to all of your users. And the more cloud-native SaaS you are in the core engine, the faster that cycle is for adding new attack content to the product. Attackers think the same way. Their ability to rapidly weaponize a new exploit, and the way they're able to do that faster than the traditional on-prem breach and attack simulation tools, vulnerability tools, and so on, further makes this time as the enemy important. The average time to exploit used to be 63 days, I think, and it's now down to less than 5 days. And it's because the attackers are moving much faster. And so on the defensive side, we have to think about time to exploit and time to verification of a new KEV that comes out. Does that make sense so far? I know CISA is an American agency, but it's had a global impact in the way that they describe key exploitable vulnerabilities and the urgency that those types of CVEs bring to companies. So with that, as a defender, when I was the CTO of Splunk, for instance, or the CIO of GE Capital, offensive cyber was magic to me. I kind of understood it, but I didn't fully grasp the techniques that attackers would take. So I'll walk through quickly what the anatomy of an attack looks like. So one, you should assume breach. There are way too many doors and windows for the attacker to get into your environment. So they will get in. Just because you think you're secure at the perimeter, irrelevant. You want to assume the bad guys can gain initial access. What can they do on the inside of their firewall with zero privileges, or maybe with certain privileges? And so you want to start by assuming breach on a single host in your environment. Think about your house. What happens if the attacker or a burglar breaks into your kitchen? Can they get to the bedroom where the jewelry is? What if they break into your garage? What if they break into your basement? You want to run scenarios from different spots in your network to understand the blast radius and the impact. And so the first thing you do is you run a single-use Docker container from me on a single host. And what that's going to do is conduct recon and enumeration of everything that's network reachable from that spot. Now, at the end of the pen test, that Docker container shuts down and you can delete it. So there's no on-prem infrastructure you have to install or maintain. There's no laptops you've got to buy. There's no agents with credentials you have to install everywhere. Because anything you have to permanently install in your environment is yet something else the attacker can target. And so you want to make this as ephemeral as possible. Run the test, shut everything down, minimize your attack surface. As that recon and discovery occurs, that knowledge graph gets built that represents the cyber terrain. And just like in chess, an attacker is going to have the first 3 or 4 moves that are the same. You're going to move your pawns, open up your bishops, open up your knights, own the center of the board. Similarly, an attacker does recon and enumeration. They execute techniques to harvest credentials or user IDs and passwords. And then they look for key processes or systems of privilege or that are likely not monitored and start there. So HP ILO, Dell iDRAC, Veeam backup and recovery. These tend to be virtual appliances that are difficult to monitor that most people don't catch or pay attention to. So in this example, our autonomous agent fingerprinted HP ILO, successfully got code execution on that host, and then dumped credentials that were in memory. Now, HP ILO stores those credentials as clear text. Many of those kinds of products do, and you don't really think about it as a defender until it's too late. From there, it successfully reused those credentials to log into a neighboring machine, where on that machine, it got access to a shared drive, found the key store file for their AWS production environment, and successfully compromised their cloud. Most cloud attacks are due to credential pivoting into the cloud versus a misconfiguration on the cloud. And that's because oftentimes you have an engineering team that left a key store file in some shared drive for their DevOps process or something like this. What's amazing here is this attack is not hard-coded anywhere in my product. It was dynamically discovered based on recon and enumeration. And so if the environment changes slightly tomorrow, it's going to dynamically discover the next attack. The other cool, interesting thing is this bank had every cybersecurity tool you could buy in the top right Magic Quadrant. Not a single security alert went off in their SOC, despite having the best products, because HP ILO is a virtual appliance with a custom operating system that you can't install a CrowdStrike or a Fortinet or other type of EDR on it. And so that wasn't being monitored or observed. So once we got code execution, no alerts went off. Once we dumped credentials, we reused valid creds across different environments. No additional triggers went off because they looked like valid logins, and we got complete domain admin and complete cloud compromise. So what do? It don't just tell me you have a problem. What do you do about it? Step 1, delete the key store file. Step 2, patch that HP ILO server. And then step 3 is improve logging and monitoring of those privileged credentials to understand if they're being abused or behaving abnormally in some way. Does that make sense so far? Cool. So when you think about your time as a CIO, my time as a CIO, there was this dreaded question I would get from the board. Are we secure? And the answer is, I don't know. Am I logging the right data in Splunk? Am I fixing the right vulnerabilities? Does my team know how to respond to a breach? I have no idea. I have to wait for the bad guys to find out. Or I have to pay consultants to come once a year and test a small slice of my environment. And that just wasn't acceptable to the board or to leadership when that was my answer. What I wanted to do was verify my security posture. For every patch Tuesday, I wanted a pen test Wednesday. I wanted to build this operating rhythm as a CIO where I was constantly testing my environment to understand where I'm exploitable. I was quickly fixing those issues, and then I was running retests to verify that the issues were fixed. So find, fix, verify is what I wanted. What was really important was I changed my reporting to the board to say, how many exploitable vulnerabilities do I have? How quickly are we fixing them? How often are they reoccurring and why within the environment? And how effective were we at detection and response? And the reason why that's important in those questions are a fewfold. What are my exploitable vulnerabilities? Just because I have the log4j jar file doesn't mean I'm exploitable to log4shell. How many people had to go patch a bunch of applications in an emergency over the holidays when log4shell came out a few years ago? You could have fixed every app, or you could have put a single network egress control in place that provided that outbound RMI JVI call. So you might have a vulnerable jar file, but you may have mitigating controls that prevent its exploitation. So I didn't care about my vulnerabilities. I cared about where I was actually exploitable and prioritized those issues. How quickly are we fixing them? I don't care about my single pen test result. I want to know the diff between today's results and yesterday's results, or today's results and last month's results. And I want to know how quickly we fixed issues, because remediation of critical exploitable vulnerabilities is the best metric to understand the health of your environment. The second best metric is reoccurrence rate. How often are issues you fixed reoccurring? And that means if you fixed a problem, you spent time and money. If it reoccurs again in a month, you have bad automation, bad training and enablement within your IT team or business team, and you're spending money fixing the same thing over and over again, which means you're not actually making progress. So I looked at reoccurrence rate as my second key metric. And then the third key metric as a CIO I looked at was detection and response time. Did you detect us? Did you log on us on that attack? Were you able to stop it? And if so, how quickly? And how do we build that muscle memory to improve detection and response over time? Because you don't want to learn how to solve a crisis in the middle of the crisis. You want to build that muscle memory ahead of time, and detection and response reaction time is important. So run a no-notice pen test, see how quickly the SOC or the MSSP detected it, and then use that as the baseline for driving improvements in your overall process. Does that make sense so far? Good? Okay. So a few things here in terms of adoption of this idea of continuous pen testing. First and foremost, our customers end up shifting from 1 or 2 pen tests a year to 40 or 50 pen tests a month, constantly finding, fixing, and verifying. And in every one of our customers, the more pen tests they run, the more problems they found in orange. And in every one of them, there was a sudden and dramatic reduction in that orange line. And that's because the red and the blue teams stopped hating each other. And they actually started to work together to collaborate and fix problems proactively. And a big reason why that occurred was trust. Because when I was a CIO and I got a vulnerability report that had a bunch of criticals, I would look at that and say, I don't believe you. Of the 100,000 criticals, maybe 5 or 10 are important. And even then, to exploit them, the attacker needs physical access to my data center, stick a thumb drive in a particular box, standing on one foot, holding a coffee, like some obscure condition. And so what I cared about was, is this really exploitable and what is the impact? So what was key in the user experience was not building a product for pen testers, but building a product for the IT admins and the network engineers that had to fix stuff. And path, proof, and impact became the most important parts of that story. So if you're an IT admin, you can look at this and say, okay, the attack started on the single host here on the left. It conducted recon and enumeration. It got code execution on a JMX server due to misconfiguration. It then successfully installed a remote access tool running a system on that host. And from there, successfully found a credential that led to domain compromise. You don't have to be a pen testing expert to read that attack path left to right. So now you understand the path. The first thing is, I don't believe you. I don't believe that JMX server is exploitable. Well, the bottom left, that's the command we ran. If you don't believe us, copy and paste that command yourself. See for yourself that it's exploitable. Suddenly, there's no doubt this is an issue. And then finally, the impact, domain admin, keys to the kingdom. So by showing every command we ran with proof, you build trust with those fixers. Because remember, that IT admin has to decide, is he and she going to skip dinner with the family and fix this problem? Or can they go home and enjoy their weekend? And if you're going to tell them to stay late, you better have a good reason for why. And path, proof, and impact became critical. The next thing is, don't tell me I have a problem, how do I fix it? Here are the exact ways to fix it. Once you fix it, you can take action and run a targeted retest that verifies that the issue has been fixed. That's why most of my users, 80 to 90% of my end users, are not security people. They're IT admins and network engineers constantly running retests to verify that they actually fixed a problem. And then that data is included in the metrics and reporting for mean time of remediation and other things you have to tell to your leadership. And I'll speed up a bit here. But when you think about why this becomes important, if I got systems access through a rat, your EDR didn't do its job. So not only did we compromise you, your security tools were ineffective. 30% of the time, we successfully defeat CrowdStrike, SentinelOne, Fortinet, and Defender. Not because they're bad tools, they're wonderful tools, but they're easy to misconfigure. So you don't want to learn about that the hard way. You want to know that your tools are effective. And you do that by seeing every command we ran with timestamp and IP, putting that side by side with your defensive tools and asking, did you log us, detect us, alert on us, stop us? The next thing, if I got code execution on that host, how can I leave behind fake AWS credentials, SQL file dumps, fake Azure tokens? How do I do pen testing and threat detection at the exact same time? Because if I can do it, the attacker can do it too. Think of it as, while breaking into your house, I'm installing Ring cameras along the way. So now you're using the pen testing results to build an entire deception or early warning network of honey tokens that you can wire directly into your SOC. So I'll end with, and we've got a lot of talks here, and we've got a booth in the back too, with the following kind of outcome. You're running a pen test. Good job. You fixed a problem. Great. You ran a retest. That's amazing. And you've deployed fake credentials along the way to trick the attackers. This is a meme that goes well usually in America. I'm testing the Swedish tolerance of memes today. Thank you for your time. I know I'm a little bit over. I hope this is a good use. And we're at the booth in the back, and feel free to ask some questions and get a demo. Thank you.